and then I'll share my screen with you. We'll just do the whole screen. All right. So open sound control. So what's funny about open sound control is that it was actually invented to replace MIDI. Um, in a way that MIDI is all wired, and a MIDI is the same cabling as DMX. DMX controls lights; they have the same connections. And ArtNet was invented to replace DMX to give you a Ethernet enabled or Wi-Fi enabled protocol. OSC was to replace MIDI, and all the recording studios of the future were not supposed to use MIDI anymore. They're all supposed to be a Wi-Fi console, and everything is going to be over the network. And but what's interesting is that of all modern digital audio workstations, I think only Logic supports MIDI, or sorry, supports OSC. You have to use a plugin for Ableton. It was adopted by the video community, and it's what drives all VJ software. It's what drives the video screens in Times Square. That's what's Madonna's concerts, the Childish Gambino concerts. This is all running on OSC, and it used to be a plugin that was we used to have to wait. Basically, I wouldn't upgrade my engine version because I was reliant on this one plugin that was a secret sauce for doing all this show control. But now that it's part of Unreal, we don't have to worry about that. So let's go to the documentation real quick. And again, OSC, Open Sound Control. And what you have are a listening server, something that's listening for data, and then you have clients. Clients are things that are sending data. In the case of face tracking, it's our phone is sending data. And we're gonna get to little blueprints, and I'll record along. And what will happen is, if you have any questions, you can let me know. I'll try to keep it as straightforward as possible and do our copying and pasting to success without having to spend too much effort. So, and what this also does is I'm going to bring in a piece of software called Max MSP, which is a visual way of programming like blueprints. And in our syllabus, which I consider a contract for things we'll go over, we never actually went over Max, even though I listed it in the course software, and this will tie up that loose end as well. So,
All failed.
yeah. So so you guys never turned any projects with Max. So so Max is a piece of software that has been around since the early '90s. It's had three different components to it. Max, which is data flow. It's all about sending signals. Then there's Max MSP, which is Miller Puckett, who's still a professor at Berkeley, who then took Max and turned it into Pure Data, which is an open source version of Max for doing music. And then there's a thing called Jitter, which is the video component, and the director of IDM, Luc Dubois, led the team to develop Jitter when he graduated with a PhD from his algorithmic composition program at Columbia. They hired him and a team of OpenGL programmers to create Jitter, which is the video component of it. I did my thesis in Max. I had never done a game or had done Unreal before. OSC was kind of invented for Max, and Max is the glue to most of my installations. It's very much like Touch Designer, but Touch Designer is a much better rendering engine. Max is a much better sound engine. So what I love about this software is that you start off with an empty slate, and it's kind of baffling. And the version that this is Max 8, Max 6, I think was the one that came out when I started school. You didn't even have this border around it. It was literally a blank canvas. And I was like, well, I'm not going to figure that out. And then I searched Max, and I searched programs that teach Max, and that's when I discovered ITP, and I enrolled in ITP to basically learn this piece of software. So, as I was saying, OSC is a protocol of UDP. Max, real quick, let me just give you a little overview. It's about objects and data flow. Whereas Unreal kind of goes left to right, Max goes top down. And you have different objects and messages and different kinds of data. So I can have let's start off with a toggle. A toggle is basically a 1 and a 0. And let's go to the next one. A button is like an off, and an on. So it's a really cool data flow program that gives you a visual way of debugging, and I use it all the time. I'm just making these larger, and so to see what the data is, I could do an object. Take an object, which can also be the word or the letter N for new, and I'm going to print. This is like my print string. Open my little console, and then I connect the wires from the output to the input. So you see ones and zeros. Take this wire and move it over to here. One. So that's a bang. Actually, it's not a 1 or a 0. That's just sending something. Right. So these things have different datas. Now I could go to a number tab, and I could bring out this, which is a little number box. Make it bigger. I guess it's gonna. I want to make it diagonally bigger. No? Oh well. You guys can see that. So this is a number box, and it's an integer, right? It doesn't have any floating point numbers, doesn't have decimal places. It's just an integer. All right. So there's that, and then all those numbers. And then what I was talking about was more normalized values from 0 to 1, like our face tracking. That's a floating point. So then if I hold down, I think here, I can see now there's a decimal point. There's a tiny little decimal point there, and now I'm going to send out numbers between 0 and 1. I can go above and below, but this is a way of doing more granular analog kind of data. So this is quite literally the values that we're sending over the face tracking from 0 to 1, and these kind of values. Okay, so I could quite honestly, if I had enough fingers or enough mice, I could manually VJ a face, right? I could use a keyboard or an Ableton controller and sliders and knobs and animate with my fingers if I wanted to, and so what's really cool about Max is that it sends this protocol pretty quickly. So we've talked about little data. Now let's talk about the internet component of it. What we want to do is we want to send, and you remember this stuff when we were connecting. We have an IP and we have ports. Every device has at least one IP that's connected to the internet. And then we can choose our own ports, which is a way of just kind of parsing things into a direct channel. We can define our own, but in general, ports 6,000 through 8,000, 6,000 through 9,000 are reserved for creative coding. When Max opens up, Max is made by a company called Cycling 74. When Max opens up, it sends on port 7474 the license authentication ping to its servers. Right, and there's ways of viewing all this UDP protocols. Adobe's constantly seeing it. UDP is being sent to your computer constantly as kind of a checks and balances system, and it's kind of fun to visualize. And there's some free software where if you want to see all the mess of stuff, if you are looking at the Unreal Epic Games launcher, it sends out data on port 6767, and if you have that port blocked, you can't actually connect to the marketplace. So it's good to know a default port, and 8,000 is a default port for doing actual OSC work with Unreal.
So basically, all these companies know when you're using the software at all times.
Yeah, it's phoning home. If you ever tried to hack Photoshop, you have to go into this file called your hosts, and you have to block ports so that it won't send out. And in the opposite way, if you're trying to play a multiplayer game or you're trying to send out data over ports, you have to go into your router and do what's called port forwarding. Mm-hmm. And you have to allow data to come along those ports. So if I were to, I'm just guessing here that this is a trick you guys could do with anybody's home router. 192.168.1.1 will always get into their router. So this is my sister's router.
Makes sense.
And I could go into the router and it's going to ask me for username and password. Well, this one's a little bit different. It has the password in the box. Usually, the password I can actually go to. I could go to school.
I love that you just have the schools systems all here. It's great.
Let's wake up the schools. Oh, this is when we're doing. Oh shit! We have a whole new way of doing a VPN too that works on Macs. I knew there was something else.
Like, in the mocap, in the black box right now, just like cleaning, and all of a sudden, all these lights just turn on.
But that's Robert. He knows us, and he expects these things.
That's true. He's like, yeah.
This was actually a test between me and Grant. We got Mac working on multi-user for VPN, so that's another thing we could talk about. So, wake up. It's that sense of wonder and play. So, let me crash in real quick. Cool. Oh yeah, everyone, your free content from the marketplace is available today for this month if you want to grab it for free.
Oh, because it's on Real Week?
No, just every first week of the month, you can go into.
Oh, and get your free things.
Yeah, the free things, and
Yeah, I remember this. Yeah.
go into the Unreal Engine.
I haven't played with Unreal on the computer yet. I'm excited. Fire it up right
Unreal Engine Marketplace, and then they're free for the month.
Yep.
Every month. So, boom, 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 boom. Some more landscapes, and they even have a multiplayer template. ArcViz. Oh, this one's cool. This is a Photoshop to motion graphics, so you can bring in your Photoshop layers to animate without having to convert it to a bunch of slices. Yeah. So anyway, back on the router and the black box, if I were to open up and go to that router, and by the way, the username and password by default for every single company is admin and password. So literally you go to anyone's house and break into their router. Just FYI. Or you can look it up. You can look up and search what is a default username and password, because no one changes the username and password of their router. So there's obviously the Wi-Fi password. That's different, but the actual admin password to get to the router is always. I don't know why I'm making a point of this. This is not what I should be teaching you. But anyway, the idea is that over the internet, you should be able to, and under usually advanced settings, do port forwarding to make sure that things can get out. Yeah. And oftentimes, like sending OptiTrack data, we have to forward the port for OptiTrack to send it over to the other computer, and that's just what's called port forwarding. I don't need to do anything over there, and we can say goodbye to the computer in the black box. Should we ever meet again? So, as I was saying, the default port for OSC for Unreal Engine is 8,000. So how do we send that? In Max, I'm going to hit N for new. It's UDP send. Okay? And then we have to give it an IP. And I am actually sending it to my own computer. It's actually not going through the outside network. So it's called localhost, which is the same thing as saying 127.0.0.1. And then I have to give it a port. And the port I'm going to say is 8,000. So now it's black. It means that it can actually it's a valid object. So what I want to do is send to a receiver. I want to receive this data. And what I can do is I can actually just receive it in Max. I'm going to say new UDP send or new UDP receive, and I don't have to specify an IP because I'm receiving it. I am my own IP, but I would definitely need to say which port do I want to receive it on, because I could be receiving information from face tracking, from mocap suit, from a bunch of different ports, and I say on this object right here, I'm receiving from the port 8000, and then to prove that this connects, even though there's no wires, we have ones and zeros are printing out, bangs are printing out, and sevens and fours and floating point numbers as well. But as you can imagine, that number's getting all jumbled together. Imagine all those things are being sent at one time. How do you send a bang to one place and a one to another one? Or how can you send multiple toggles and say, I want one toggle to be one for one place and another toggle to be for another place, right? How do I differentiate between these two toggles? If this one's supposed to be controlling one light and this one's supposed to be controlling another light. And this is where the internet component or the URL component comes on. You need to send it on a network address. So I can prepend an internet address, light 1. Here, and delete that. And then the next one, it would be light 2. And then connect that in. And let's move these over to the side for, oops. Move these over for the side for a second. Alright, so now when I receive, you'll see that light 2 is turning off and on, and light 1 is turning off and on, right? We've now differentiated between these by using an internet protocol. And this can actually be a very complicated URL, but we'll keep it simple for right now. So inside of my game engine, I could make light 1 turn on one light and light 2 do the other light, and they wouldn't interfere with each other. Right? Yeah, it's straightforward. It's just kind of sometimes it's a new concept, and it just needs to be worked out. So that's great, but all I'm proving is that I'm sending data to myself over one piece of software. This doesn't seem too magical yet unless it gets into another piece of software. So let's try to go over to Unreal. We know that we know what port and we know what IP we're using. Right now, what I've done is I've bound to port 8000 on receive. I'm going to unbind. I'm going to delete it, because I need to open that back up so that Unreal can bind to that. Alright. Let me just put this in my desktop. I can send this to you guys later on. This is...
Sort of nerdy quick question. Can Max talk to Bleepini as well?
Yes.
Okay.
Max can talk to anything. Max is how you connect your printer to your toaster. Which I'm sure can be done. So let's go to Unreal. Let's go back to the documentation, because I don't want to have to code all the OSC stuff from scratch, especially since in the first production class we didn't really do a primer on blueprints. So I could have sworn that in here I would say it said clip the copy node graph button on each image, and it will give me the blueprint. So what's cool about blueprints is that they're actually formatted as XML, and you can copy and paste them as text over chat, over Slack, over email, or just on a clipboard. So what I have here is I don't want to send, I want to receive from Max. So let us receive on an address. I went to all the zoom in.
This is giving me ideas. This is so exciting. Okay.
So you see here, we're going to be looking at which IP address and which port, and then I need to be able to, when I receive them, I need to be able to get all of them and then get different values. So I think I'm good with this one. Copy it. Great. And then I'll come back over to Unreal. So let's just do a blank map real quick. So let's first of all talk just real quickly about key presses and visibility or something like that. I'm going to put a cube in here, and let's say I want to toggle this one's visibility. I'm going to go to my level blueprint. Level blueprint is where you kind of prototype things, and you can use key presses. Once you start seeing that you're doing something over and over again, you're going to make a class so that you can repeat that on objects of those class, and that's the basic fundamentals of object-oriented programming. But for right now, let's just make a box appear and disappear. With it selected in the outliner, cube right there. My blueprints are context sensitive. If I right click, it says context sensitive. It's only giving me all the functions for that Unreal can do with that box. If I unclick this checkbox, here is all 8 gigabytes of functions you can do in Unreal. So you can just search and like learn things that can be done in C++ by reading this list of unabridged list of functions. But this is all the functions that deal with cubes. And the first thing we're going to do is create a reference to a cube. And then what I want to do, I want to toggle its visibility. And there it is. By searching for the letters T or G, I know that toggle visibility can be turned off and on. I want to use the letter P, so I'm going to type in input P. That wasn't as suave as it used to be. It used to be much easier drilling down. There's my key presses. I'll use P. And then the white pins are execution pins. They execute things. And as I said, it's from left to right. I want to compile and save. This is called OSC map. And if I hit play, let's find that cube. I can hit P, and it goes off and on. Right, so that's how quick it is to do to program interactivity and Unreal Engine, and with the beauty of blueprints. If I wanted to, while it's still playing, I could debug and hit P and watch it fire off. Oh, well, it's not firing off. Sometimes it does, sometimes it doesn't. I forgot why. But sometimes you can see it executing with, like, it shoots a little pulse of energy down, and that's how you know that it works. And it's a visual way of debugging.
I'm sorry, I might have missed something. How is this talking to OSC right now?
It's not.
It's not. You're just showing me the basic.
I'm showing you the most basic interaction inside of Unreal.
Cool. Okay, I see.
Mm-hmm. So, what I want to do is make this interaction being driven by OSC. Dun dun dun. Just what you're talking about.
Got it.
So instead of doing this in Unreal, I want to do it in Max, which could also be my phone, which could also be an iBlink, which could also be an amplitude of an instrument. We want to create a way of sending a 1 or a 0, or just a bang to this toggle of visibility. So what I'm going to do now is, escape is unfortunately for Zoom and not for Unreal. There's a better button than escape.
This is making me so excited, though.
Just go away.
You could have sensors in a performance and have an actor like emote something and create particles based on that emotion, or music, music, and you can make things visualize or manifest based on the passion of the person.
Yeah. So I'm gonna go in here in this map, and I still have my clipboard, that OSC stuff. I'm gonna hit paste, and there it is.
Oh wow, that was pretty smooth.
Right. And then what I want to say is I want you to create the OSC server when I hit play, which is this event begin play. If anyone who's familiar with processing or P5 or JavaScript or anything, where you have a void setup and a void draw, this is your tick that happens at the very beginning, and this is the every frame. We're going to do event begin play. When I hit play, create my server. My server is on 127.0.0.1. That's the shorthand for localhost. Our port is 8000. And then it's going to get all the messages, blah, 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 junk, and it's going to print it to the string. Let's just see if it works. One quick little note is that when Unreal knows it, it's a beast for performance. And what happens is when Unreal gets pushed to the background, it lags. It goes into like CPU hide mode. One quick little trick when you're doing two pieces of software at the same time is go to project settings, No, I was lying to you. The trick is to go into editor settings, and when it says performance, make sure that use less CPU in the background is turned off. I think it is turned off by default now, but it used to not be for 5 or 6 years. Okay, so we want to be able to, we're going to be printing to string right now, or printing to screen. So we're going to play, and if these do handshake, then it should print to string up here on the very left. Let's bring it max. And let's see. No. Let's see if... that makes sense. That makes sense. Okay. Nothing there. Let's see if we're getting anything on the inside. Here. Cool. Nothing there. Nothing there. Cool. And what I did before was already made one that was working. Ah, that was all fine. Let's close that because I might be stealing. 1 second. It might not be able to do this in level blueprint. I was trying to build out slowly from level blueprints, but let's just see. Play one more time. Toggle. All right. So let us talk just real quickly about objects. I have classes and class blueprints. Once you find something like every time I see a door, I want the door to open, you would want to program that in a level blueprint over and over and over again, right? Door open, next door open, and then you're creating tons and tons and tons of maps that are using that blueprint over and over and over again. And if you're ever doing a thing repeatedly, then there's a smarter way of doing it. So the level blueprint is for things that would only happen in your level, but there's any kind of interaction that happens over and over again, you're going to make a class of that one. So you can make just one door blueprint, and it will always happen. So a classic one is to, as we've already toggled off and on a cube, I can recreate that inside of a class blueprint. I'm going to go to Assets, Blueprints, and create one called BP Cube. And then I'm going to drag it into the world. It's empty right now. That's called an empty actor, just so you see where it is in space. And then if I tear that off, as I build it, we can watch it build. And I want to add back in a cube. Right here, here's all the components I can add into a blueprint, just like everything I can drag in from over there. I'm going to do a cube. And now, see, if I build a cube here, it's also in there. So I can see a visual reference for this cube. If I move it up, it moves up over there, etc., etc., etc. So I want to now, let's actually do a sphere for our purposes. Make this a little bigger so you can see what I'm doing. Sphere. Cool. And you see that's updated. So what I want to do is I want to be able to hit the sphere, and I want it to turn off and on. Alright? So let's go ahead and go back into my blueprint and write out that code that we know. Here you see that event begin play, and you see that event tick, and what I want is to say sphere. I want you to toggle visibility. Great. But instead of a key press, we want it to be when I overlap something. So I'm going to use invisible geometry called a collision. And when this box, when I collide with this box, it's going to toggle it for me. Cool.
Hmm.
Again, this is kind of the idea of context sensitive. If I right click on the box, all the events it can trigger are right here. And so I want it to be that when I overlap, when I go into it, like if I was going to build a door that opens up, when I go into this this invisible collision, door open, and then when I leave the overlap, door close. But for right now, we're just going to say when I begin overlapping, trigger this. Now, there's a whole bunch of other different things we can use here to drill down to what is hitting it. Is it just me? Is it just another player? We could be more specific, but for this case, if anything hits it, toggle it off and on. And as I said, this is an invisible component. It's not something you'd actually want to see in a game, right? It's invisible there. I'm going to make it visible so we can debug a little easier. So we go back into our blueprint and just say, make sure that you're not hidden in game. So let's see if this works. Play. If I hit box, it goes away. Right? Interaction. There's a little collision around the camera. That's why it's working. To go back to another point, this should be visible. There you go. So now you can see the debugging. Right, this is like Touch Designer. You know where it's being triggered. And so what's the idea of an object of a class is that once you have a class of something, you can make objects of that class. Each one has the same properties, but they can be controlled individually. So you get a car, and 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 you get a car. Right, these are all objects of the same class called BP cube. And as I run around with them, they all have their own individual properties, right? This one is only disappearing, not all of them at once. They're all individual objects of the same class, but they have the same property. So very, very fundamental core concept of object-oriented programming. And this is how you save yourself from, doing a bunch of repeated work. Right? Keep on.
Is this workflow in Blueprints at all similar to what you can do in Babylon JS?
I'm not familiar with Babylon JS.
Or like WebGL, because I've seen kind of these visual programming interfaces in some web languages. And I don't know if that's more of an emerging thing, but for people who are trying to bring real time into the web, I wonder if it's trying to approximate some of this.
Are you talking about like the actual look and feel of blueprints or the functionality of blueprints?
Functionality, just the sense of like logic.
Well, the logic and everything, what's the underlying core structure of this blueprint is that these are actual C++ functions, right? I can hold down Control and Alt. Well, this one doesn't, but I'm also still playing. There's a C++ function that's written here, and if I open this up in Visual Studio, I could see that code. And if I was using some C++ function enough, I could turn it to a blueprint and then have that blueprint. And that's what a lot of the content in the marketplace is, are C++ code that people have turned into blueprints, so you don't have to do it yourself. So what's really cool about doing blueprints is that you're actually using the terminology and logic of C++. So it's actually a didactic tool that's teaching you C++. And if you pseudocode a blueprint, if you pseudocoded that same blueprint idea to somebody who's using Open Frameworks or Cinder, they would know exactly what you're talking about because they're doing C++ too. So that's kind of the beauty of learning blueprints, is that you're learning C++. Toggle visibility is a function of C++.
Wow.
Yeah.
It's a beautiful abstraction of it, because that's pretty dense.
Yeah, I mean, C++ is one of the harder ones to learn. That's a beautiful and very fast optimized programming language, but it seems to be defined by its exceptions versus its rules, very much like the English language. So what we want to do now is see if we could potentially get into this toggling as an OSC thing. So I'm going to try to copy and paste in this OSC again. And on my we can play, I'm going to say 127.0.0.1 port 8000.
Oh my god, this is giving me so many ideas though.
And then this should just print this out raw and see what happens. Alright, so each one of these is now an OSC actor. Darn it. Let us... What's going on? What's going on? Let's see if localhost is not a thing. Let's try localhost. Yeah, literally. And hit play. It seemed to... That was just event being played. Let's stop here. The great thing about Max is that you don't have to compile and uncompile, so I can continue to edit while Unreal's running. So you can like live code your interfaces. Alright, so what I'll do is I made one previously, and let's just take a look at it, see if it's still working, see if it's systemic with Unreal or if it's my blueprint. So let's go into another map. Yes, levels.
What version of Unreal are you in right now?
I'm in 425.
Okay.
And that's kind of the beauty of the OSC being native to Unreal is I don't have to worry about waiting. I don't have to stick back a version anymore.
Yeah.
So in main, I have BPOSC, which looks very similar. Port 8000. What's my IP address? Oh, so that might be the difference, is the fact that I was actually not using localhost, but I was using my actual local IP address. So my IP config is .187. So without even finding out if this works, well, let's see if this works. Nada. Do I have on a bunch of ports? No. Let's go in here. Yes, yes, yes. And then this shall work. Let's say one fader. So I'm going to write out a new address. Float. And we're going to say this is me just debugging light 1. Oh, these are sent backwards. Somebody should have stopped me on that. You mind your slashes. You mind your slashes. Alright. Let's change this to 192.168.1.187. Oh, it looks like it was running. Okay, it's running. So that's all it was, is that instead of doing localhost, the new OSC plugin wants you to specifically use the correct IP. I guarantee you that there's other ways of thinking about it, but let's just make this work for now. So, to reiterate, what was I doing wrong before? It was actually these slashes were in the wrong place. Went back over here. let's go back to using the right URL. 192.168.1.187. Okay, so you see the left side, ones and zeros. So I made it overly complicated. I was trying to be smarter than I really was. But what we've proven is that we have two pieces of software.
Well, you could totally see where this comes in handy, though. Like, imagine, like, taking, like I said, like, a heart monitor, you know, and linking it to Unreal. Like, what manifests when someone's getting nervous or, you know, when their breath is being changed. That's what I'm thinking a lot of.
Yeah, I mean, every single sensor can now be put inside the game engine.
Yeah, that's insane. Yeah. I mean, it seems like the modern equivalent of, not really modern, but like 5 years ago, Cat Sullivan's thesis being like the particles, you know, coming out of the motion capture. You know, like this is just that, but now in a simulation.
So now we have, I think I want to be a little more flexible. Ents, of course, round off. I want to get OSC message. OSC message from float. Or what I could just do is, since this one already works, let's just say, great, I already have one that works. So let's bring in that object. So I can move on. Okay, so BP OSC. So now if I hit play, that's cube. Let's delete, save, whatever. Let's get rid of let's not trigger it. Sorry, a little cleanup on my end. I told you I didn't rehearse this one, which goes to show and prove how much I actually do rehearse for the ones inside a class.
Yeah, they're pretty succinct.
So what I want to do is create an address. And what I can do is I can create a whole list of addresses, and then they can be called Light 1 and Light 2.
I just want to put sensors on everything on set now.
That was supposed to be Light 1, and then I could duplicate that one. Let's say Light 2. And so these are both. Print those values. So here we go with Light 2. And then we got Light 1. It's two separate values. So let's make this do something useful. Let us say that what I want to do is instead of having just nothing in here, I'm going to put a light. Alright, so now I can see that there is a light. Where's BPOSC? Right here. Voila, a light. And I want to send something over to light. As I said before, Max is really great at audio, both sending audio but also parsing audio. It can convert live audio samples to MIDI. It can live transcribe it to staff. Like, it could do all sorts of stuff. What I want to do is I want to bring in my voice. So let's bring in, what we need to do is we need to convert a analog to a digital sound. So we're going to convert an analog to digital converter, which looks like a microphone. And then I want to register the peak amplitude. These are all just max objects. They really don't have any logic. I want to do it every 33 frames per second. And I want to look at this number in real time. If I turn it on, we can now see that, woo, I'm sending out volume of my microphone to this. It'd be much easier though if I had a little scroll bar. So I'll do a multi-slider. And I'll go into my little properties, and I'm going to turn it into something between 0 and 1. And I want it to be a line scroll. So now you can see the volume of my microphone. Maybe this is a little bit quiet for the interaction I want. So we can scale it from 0 to 1 to 0 to, I don't know, 3. We're just going to take a value and make it a little bit amplified. So now you see, oh, that looks much, much, much better. But again, what's great with Max is that if I wanted to, I can, it says that's the high output value, that's that 3. I could put a little floating number here, and in real time, I could adjust how loud I want it to be. So quiet, 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 getting louder and louder and louder, and I can live manipulate this while I'm doing my show. So this is why Max or Touch Designer is a really great interface for controlling all these OSC connections. Right now it's a little jagged. I know from doing a little bit of VJ that things should be smoothed out, and usually you want to be able to tell the onset of a beat, so you want no smoothing when it hits, but you want a little bit of a decay, a slow decay as it releases. That object is called slide. So what does slide need? Slide needs a float value up and a float value down. I don't want any delay, so no milliseconds, and then all the way back down you can smooth it out over 10 milliseconds, and this is the same smoothing function that you would find in processing or P5. So now you can see how it trails off when I get done talking. That's literally how you want to do beat detection. And you want to hear it immediately, but then you want it to fade off so people can see the interaction happening. So boom, or which is this microphone? No, it's a computer microphone. I can change it. Cool. So we're just kind of going down a little tiny rabbit hole. I'm going to bring in my new one. All right. Looks nice. I can tap it. There we go. Cool. All right. So let's get this into the game engine. So this was sending out nowhere, but basically we're getting values between 0 and 1. If I then, and again, this could always have been playing, right? I don't have to adjust Unreal. I'm now connecting all this stuff in Max in real time, and then eventually this value is going to go to light 1. So let's just take this and go to, I think it was light 1. Is it light 1? No, it's light 2. Light 2. Let's see. Where are you? It's supposed to be light 2. Great. So let's now let's adjust the blueprint. When you have a component, you have all the details for the component. And one thing I see is every single one of these details, these are all attributes, these are all parameters. These can all be exposed in blueprints. And I think the easiest one for me to do is maybe do intensity. And we see right now by default is intensity of 9,000. Mm-hmm. So I want to drive this between 0 and 9,000 to make a little audio reactive light. I can go ahead and tell you that I can either dial it in here and say 9,000 from 0 to 9,000 here, and let's go ahead and add in the interactivity on light 2. A bunch of other stuff I've been doing. Let us execute. Again, what do we want to do? We want to set our intensity. Mm-hmm. So if I just drag off and say set intensity, I'm just stumbling forward and just searching for things I want to have happen.
Yeah.
And what is my intensity? It's this value.
So you're just stringing all these things.
All right, let's hit play, and now I have an audio reactive light. Right, so maybe it's not, maybe it's fading out too slowly. Then I can change this number, because it's the slide down number. So now it's much quicker, it's much choppier, right?
Got it. Yeah.
Or I can go back up to 10, or I can make it really trail off, right? So here's how you're doing data flow in one piece of software and sending it over to another software. And anything you can think about, position and scale, right? So I could take these spheres, and instead of being just a light that's going off and on, I can make it a cube. And instead of being scaling intensity,
Sure.
I can grab my cube, and I want to set my scale. So I'm going to write in the word scale, and there, I have world scale. I knew scale was it. I'm going to convert a float to 3 floats, right? X, Y, and Z. Does it automatically for me. And now we're going to end up making a crazy thing 9,000 centimeters tall. Let's see how that looks. That should be pretty dramatic. Oh yeah, that was a little crazy. I don't know if you guys saw that. That is a little much. Let's just do it on a couple axes.
Do it to the base.
Instead of making all of them be the same value, I want to split these scales up and just have it drive the vertical. Let's keep these at, I don't even know what they were at before, 1 and 1. To find that again, let's just double click on it. There we are. Hey, what's up? Oh my, that's dramatic. That might be a little much. Let's bring it back down to, I don't know, maybe only 500. Okay, now we're rocking and rolling. Cool. So this is one value, and this is running on light 1. But you can imagine I could do some sort of EQ filter, and each different address can drive its own box, and each one could be like its own equalizer that's growing in size audio reactively to my voice. So this is just an idea of how to connect a little bit to get you guys interested in the next level of using OSC, which is literally the most used protocol that I deal with all the time, and it's basically the invisible connection to everything inside of the game engine world. Now, obviously, you can do serial and you can do other things and have dedicated plugins for this. But for my prototyping needs, I do everything in Max first, and then I decide if I want to, because I could do serial in here, I could do DMX in here, I could do everything in here, and do my synesthesia of converting voice to whatever I want, and then we can figure out the better solution for it later on if we need to package it for a store or put it onto computers at installation. So that's all I really wanted to show today, was just how to use the new plugin, how to copy and paste to success. Do you guys have, I'm sure there's questions, but anything that's comes to mind about this stuff right now?
Yes, I have a ton of this is amazing. Just give me 2 seconds because my seamless guy's downstairs. I'll be right back.
Alright, looks like I lost my Zoom, so I'm going to stop.